Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we are going to start a new course which is part 2 of textiles for human protection. As has already been mentioned that the area of human protection by textiles is very wide. So, it has been tried to include major textiles for human protection, and as the area is very vast. So, it was not possible to include the material entire subjects, all the subjects in one course of 40 hours. So, that is why it has been divided into two parts. So, in earlier course which is textiles for human protection part 1, we have discussed various textiles for human protection, and now we are going to start the new course which is textiles for human protection part 2. In part 1, what we have discussed, the areas like first we have started with the introduction to textiles for human protection and the functionality. After that, we have covered different fibers, yarns, fabric constructions for human protection. So, wide range of fibers and their possibilities, how the yarn structures are affecting the human protection and even different fabric construction. Then we have covered the textiles for protection from extreme heat. So, there we have covered various extreme heat related areas like molten metal, flash fire, radiant heat, everything we discussed in that portion. And then textiles for protection from extreme cold, that part we have covered in part 1. After that, textiles for protection from ultraviolet rays, how we can protect ourselves by designing the clothing and proper selection of fiber, what are the different type of fibers, their absorbance category, and also the UV index. So, detailed study we have explained there, and also research study we have covered in that module, and followed by we have covered the pollution. So, pollution is a very wide area, particularly in air pollution and water pollution. So, textiles play a major role in controlling the air or water pollution. So, air pollution we have covered in part 1 of this area of this course, and in part 2 we have started with the water pollution, how textiles help in controlling the water pollution. So, After that, now we are going to start the part 2. In part 2, the textiles for protection from water pollution. We will start with the water pollution, how textiles control the water pollution, and then there is a major human threat, that is from mechanical threats. So, we must protect ourselves different types of mechanical threats. So, during daily activities or even during the military activity or industrial activity, we come across different types of mechanical threats. So, there the threats are like ballistic threats, threats like cut related threat, then slash related threat and stab related threats. So, all these mechanical threats, how the textiles help in controlling this or protecting us from all these threats, that we will discuss, along with some research studies also we will discuss. There are standards, different standards available, what are the different types of structure, fabric structure, yarn structures. So, all these things we will discuss in this module. After that, we will discuss the protection against noise pollution. So, the noise is a great, it has great impact on human health, and how we can control the noise, that all the details we will discuss, and also some research studies. So, noise control by textile is not new concept, but with the development of human activities, urbanization. So, noise level increases and we have to protect ourselves from the noise pollution, and how textiles help us in protecting that aspect we will discuss here. Then in many places people are actually exposed to hazardous gas and chemical. So, the textiles can protect us from this hazardous gas and chemicals. So, those textiles detailed we will discuss, what are the type of coatings, what are the textile structures, everything we will discuss, cover here, and different standards we will also cover here. Then textiles are also used for microbial and viral hazards, like in hospital PPE kit and all this. So, how the textiles help us in all this protecting ourselves from all these hazards, that we will discuss in this module. And in automobiles, automobile body, it is made of composite, some in major part of automobile body is made of textile based composite, but airbag is one component in the automobiles which directly protect the human. So, that airbag component we are going to discuss in this segment. Also in automobile there are many other textiles that we have discussed in different modules, like in automobiles for human protection from the pollution, air pollution, textiles are used, but that part we have discussed in air pollution control part, but airbag is basically is an entirely different concept which protect the human being, and airbag is becoming the mandatory requirement of any automobiles. So, that we will discuss what are the different type of structure, how it works. So, everything we will discover in this section, and finally, we will discuss the smart and functional textiles for human protection, and also how the protection and comfort, their trade off, how we should deal with this trade offs. Like if we want protection, then we have to sacrifice comfort and vice versa. So, that how all these aspects we will deal, that will be discussed in this module. Now, let us start with the textiles for protection from water pollution. First, we will discuss the basics, what are the different types of pollutants are there, and how are they work, and how textiles help, and after that we will discuss the different types of membranes, textile based membrane, and also the research studies where we will be discussing one development where nano technology is used to develop one water purifier, which will be used in particularly rural area where there is no power. So, let us start with the textiles for protection from water pollution. This module is a module 6 in this series. So, here we can see we get pollution from industrial exhaust, that is air pollution, that we have already discussed, and also industrial effluent that actually pollute our river, lake. So, that how textiles help in controlling this pollution, that we will discuss. Like contaminated water is coming to the directly, if you throw it, and it will directly come to the river, or finally the total ecosystem will get disturbed, and instead of directly discharging this water, we should use the water treatment plant, where textiles can play a great role, and after water treatment we get clean water. So, all these things we will be discussing in this module. Let us try to understand the overview of environmental pollution first. So, as I have discussed, like particulate matter are there, volatile organic matters are there, even agricultural some toxic material. So, that also comes along with the water and gets even dye from the industry, industrial effluent, even domestic effluent. So, everything pollutes water. So, we need water filtration for now. See, environmental pollution includes the contamination of air, water and soil. So, this is actually contaminated by different particles and the different activities of bacteria and all. So, we should protect ourselves protect the water. So, air. So, air pollution we have discussed. Now, we are discussing the water pollution. So, major pollutants are particulate matters, heavy metals are also there. So, heavy metals mixed with the water is harmful for human health, dyes, volatile organic matter, pathogens. So, different types of matters are actually particulate matters are there in the water. So, that we should try to address. The concentration of pollutant in air, as we have discussed. So, it is this is the concentration, it is milligram per or microgram per cubic meter. So, microgram per cubic meter normally we express in case of air, and in water either milligram per liter or microgram per liter. So, that we can express the concentration, and concentration is very important, concentration along with the particle size. So, these parameters are very important for controlling the or restricting this particulate matters from exposing to the clean water to mix, we have to restrict there. And air pollution is little bit, air pollution control is little bit easier than water pollution control, because the dye particles which are toxic in nature, which mix with the, actually they are they mixed with the water. So, we have to clean it not only by the textile structure, but also chemically. Okay. So, that is why water pollution control is little bit tricky. So, textile filtration media. Okay. So, textile filters provide sustainable solution for pollution mitigation. That means, we can control the this say dye or any other soluble matter by applying the chemicals, but that may not be sustainable. But textile, if it can restrict the dye physically, restrict the this particulate matters physically, then we can actually achieve the pollution control without any additional addition of chemical. And also textile can actually can be reused for repeated application. Now, let us try to see quickly the environmental impact of air and water pollution. We have also discussed earlier in air pollution segment. So, particulate matters PM 2.5, which means that it is a diameter of these particles or width of the particle should be less than, whatever particle less than 2.5 micron, it is called PM 2.5, and the problem is that it penetrates deep into the lungs or bloodstream through inhalation. And WHO recommends the PM 2 limit, which is safe for human health, is 5 microgram per cubic meter. Air quality index for PM 2.5 should be 5. Water pollution increases BOD, biological oxygen demand and chemical oxygen demand. So, this is very important. So, BOD and COD control is very important for water pollution control. High pollutant level disrupt the ecosystem balance and human health. So, the aquatic animals, they get affected with the high pollution level in water. So, that will disbalance the ecosystem, and obviously human health is directly affected by high BOD COD in water. So, how now see how textile materials can contribute to control the pollution. So, air pollution we have discussed. So, fibrous material, fibrous structure acts as porous filtration medium. So, the advantage here is that it will allow the medium to pass, but it will restrict the particles. Okay. That is important. In case of air pollution, air filtration, the medium is air, and in case of water filtration, the medium is water or any liquid. It is not, we are not discussing only the water pollution, water filtration. For any liquid filtration. So, fibrous material captures the pollutant, okay, through mechanical and electrostatic interaction. Electrostatic interaction we have discussed, it is only for this air pollution. Through mechanical entrapment, the particles are also captured majorly. So, the filtration efficiency in case of air filtration particularly is expressed in the particle which is in upstream side minus particle in downstream side, and expressed in ratio of particle in upstream side and expressed in percentage. This C may be in the particles may be in terms of number or may be in terms of mass weight. So, eta is a filtration efficiency. So, particles concentration before filtration, that is inlet, and C out is particle concentration in the outlet. And here that filtration efficiency means how much the particles it is arrested by the filter. So, it restrict. So, here in textile material the main advantage is that high surface area volume ratio, and which helps in adsorption of the pollutant. That is advantage of textile based filter. Now, let us try to see what are the different types of classification of textile based on. So, textile based filtration systems. So, textile air filter for particulate removal, that we have discussed already. Now, we are going to discuss the water filtration. Mainly it is done through membranes. Membranes may be textile based membrane or may be other polymeric membrane. So, nanofiber based membrane is nowadays very popular, which actually help in removing the particles in nano level, and also the advantage of textile filter is that we can treat this fiber, we can modify the fiber structure by incorporating nanoparticle, which helps in controlling the microbial filter, which will restrict the microbial growth. So, all this we will discuss in this segment, and also adsorptive textiles composite for chemical removal. So, we can modify the textile surface, textile fiber, which will make it adsorptive. So, that adsorptive textile composite we can develop, which will help in removing the chemical. Also some volatile material like even on odor, that we can remove through some additives, and also catalytic filtration, that the textile for pollutant degradation. So, we can treat the textile with some catalyst, and this catalyst will help in degrading the pollutants. So, that also by modifying the textile structure, textile fiber, we can control the pollution, water pollution. So, if you see all these three are basically for liquid filtration or controlling the water pollution. So, the types of fibers which are used, what are the different types of fibers which are used? So, natural fibers like cotton, cellulose, wool with hydrophilic properties. So, we can use the hydrophilic properties of natural fibers to control the water pollution, that we will discuss. And also the synthetic fibers are used for their durability, for different other characteristics. Synthetic fiber main advantage is that we can control the fiber diameter. So, that we can use, like polypropylene, polyester, polyamide are used widely for water filtration, and also so advanced materials are also used. Advanced fiber like carbon fiber, graphene coated fibers are widely used for water filtration. So, this type of fibers are used, and as I have mentioned, nanofibers typically have diameter 50 to 500 nanometer, are widely used nowadays to control the both air pollution and water pollution. Now, activated carbon we can use for textile filters, particularly for water filtration. Activated carbon is widely used. So, textile fibers are treated with activated carbon, like on the fabric surface the activated carbons are deposited, and that helps in particularly water filtration. Even in air filtration we have discussed that activated carbon textile filters are used. The main advantage is the huge surface area, like 800 to 1500 square meter per gram. So, that is a surface area of activated carbon, which helps in absorbing the chemicals or odors, which absorb volatile organic compound, which are actually mixed with the air or water. So, that all these compounds are absorbed due to the very high surface area of activated carbon, and this activated carbon are, this is the fiber surface, and activated carbon is actually deposited on the fiber surface. So, that activated carbon adsorb. So, the textile material physically restrict the particle, but activated carbon here it adsorbed the volatile organic compounds. So, if you see the Langmuir adsorption isotherm, that relationship if we try to see here. So, Q equal to Q max K C by 1 by K C, this is the Langmuir adsorption isotherm here. So, Q is amount of adsorbed on the surface. So, that how much, this is the volatile organic compound, it is this is the adsorbate. So, this is Q is the how much it is getting adsorbed. Okay. Q max is the maximum adsorption capacity. So, how much Q max is the maximum capacity, and Q is the how much quantity it has actually adsorbed. So, that will give us the idea of the efficiency of adsorption. So, this is the Langmuir's adsorption constant. So, affinity of adsorbent. So, K, this is the constant. So, for different adsorbent they have different level of affinity. So, K value changes with the type of adsorbent and this material activated carbon. So, C is the concentration of adsorbate in the solution or fluid. So, that means C, this is the concentration here. If the concentration is high, then the quantity will increase, but not in that straight line, because in the denominator also it is there. So, it describes the monolayer adsorption of molecules on the surface. So, it is a monolayer adsorption. So, this is the activated carbon, and suppose volatile material is showing in the, these are the volatile material here, it is getting adsorbed here due to the activated carbon. So, here this is adsorbed by the this activated carbon, but this equation will be valid for monolayer in one layer. After one layer of this adsorbate is adsorbed on the surface, then this activity will be changed, and this in that case this equation will not be valid. So, this is the overall idea of Langmuir adsorption isotherm. So, for different material and for different adsorbate, the value will be different. So, this is used for respirators and industrial filtration. So, this different applications are even for residential, for home water purifier we use the carbon, activated carbon. So, what are the sources of water pollution as we have discussed? So, industrial wastewater discharge, which is huge, and where the wastewater, there are different regulations. So, an industry cannot directly discharge the wastewater. So, they can only discharge the water after treatment. Agricultural pesticide roundup. So, through agricultural in the field they we apply the pesticides, and during rain it washed off and mixed with the water body. Domestic sewage contamination. So, we discharge at the domestic different types of sewage. So, effluent COD, this can go as high as more than 500 milligram per liter. So, huge quantity of that effluent COD is there. So, that we have to remove. So, major water pollutants are, you see that is a heavy metal. So, different types of heavy metal is there, okay. Lead, cadmium, so different types of. Then organic dyes. So, in the particularly in textile industries, the dyes are used, the organic dyes are there, and that can go as high as 10 to 200 milligram per liter concentration. So, that dye if we discharge, that will actually be the source of water pollution. Here you can see this is the, in wildlife, if we see there is no water pollution, although there may be chance of air pollution due to the wildfire, but here at basically at the industrial level and domestic residential domestic activity, where it is that urban activities, that is the main source of water pollution. So, microbial contaminations measured as CFU, and suspended solid increases the turbidity. So, in during flood and all other activity where the water comes along with the soil or many other microorganisms, that also pollutes. So, there is a man-made pollution and also natural pollution comes, and which increases the turbidity of the oil, of the water. So, all these activities we should be restricting, and we should clean our water for protecting the human health. So, water treatment is extremely important, as we have mentioned the different sources of pollutants. So, before we discharge this water to the water body like river, pond, lake, we must treat this water. So, drinking water turbidity less than 1 NTU. So, NTU means nephelometric turbidity unit, it should be less than 1 for drinking water, and safe pH is 6.5 to 8.5, it should not be too acidic or too alkaline. It should, the BOD and COD level should be as low as possible, and it should ensure the safe potable water supply. So, all these things we should have. We can actually treat water by chemical process, using chemical, and also by the textile material. Typically what we do in combination of chemical and also by using textile material. Textile material helps in controlling the turbidity. Turbidity is actually by physically arresting the particle that we can control. Now, controlled release of antimicrobial systems. So, textile membranes in water filtration are used. So, why textile membranes are used? Because it has got high permeability. So, it provides high permeability, it should allow the water to pass through by restricting the particles. So, that is why fibrous membranes are used. Membranes, fibrous membrane has got very small pore size. So, it can restrict the microbial organisms. So, this high permeability, we need the flux of water. So, water flux relationship is J equal to B by AT. J is the membrane, textile based membranes permeability expressed in terms of a liter per square meter per hour per unit pressure. So, volume per unit area through unit area per unit time with a unit pressure. It is similar to the air permeability, that is membrane permeability used in water treatment plants. So, this air permeability is very much useful, that this fibrous membrane is used in water treatment plant, where we need to know the permeability. So, it should have very high permeability, otherwise the volume of discharge will be very less. So, that will actually load, the efficiency will be reduced. So, we need a product like textile filter. The main advantage, as I have mentioned, it has got high permeability. If the permeability is less, that means the whatever the discharge is produced in the industrial activity, that will not be able to treat this amount of discharge. And also we use the microfiltration membrane. Different types of membranes are used, we will discuss in detail subsequently for water filtration. Microfiltration membranes pore size 0.1 to 10 micron. So, microfiltration. So, there are different types of membranes. So, microfilter membrane pore size is 0.1 to 10 micron, it is a larger size. So, pressure use 0.1 to 2 bar pressure we use in case of microfiltration membrane, and it actually removes the relatively larger particles, like remove suspended solid and bacteria. Although bacteria size is depends on the particle, that pore size, we can restrict or we can remove the bacteria. So, it is a common in water clarification. So, this type of for any large size particles are there. So, water to clean the water, we use this microfiltration system. Then ultrafiltration membrane, one is microfiltration, then ultrafiltration membrane. Here if you see, the size of pore is much lower than this, 0.01 to 0.1 micron. At that level, this is the ultrafiltration, next level, and ultrafiltration by textile material we can use. So, you can see the in case of microfiltration, the pressure drop was 0.1 to 2 bar, and ultrafiltration the pressure drop will be more than that, typically between 1 to 5 bar, because of the lower pore size. So, lower pore size we have to actually allow the water to pass through at a certain quantity, certain volume. So, for that we have to apply little bit higher pressure. So, 1 to 5 pressure it works, the ultrafiltration. It removes viruses and proteins, different types of viruses we can remove, because the size is very small, 0.01 to 0.1 micron. So, we can use it for drinking water purification. So, ultrafiltration we use for drinking water in our home water purifier. We use this type of ultrafiltration system. Then nanofiltration membrane. Nanofiltration membranes are pore size is, you can see it can go as low as 1 nanometer, and here it can actually stop. Pressure is much high, you have to use the higher pressure here. So, for reverse osmosis we use this type of nanofilter membrane, and it removes the salt and different ions, okay, organic molecules. So, different types of molecules we use. This is used in water softening to make the water soft water. From the hard water we can use this nanofiltration, because it removes all the salt and different types of divalent ions and organic molecules, so that water becomes softer. Now, another problem of water pollution is that oil spilling. So, here to restrict or to counteract this problem, to solve this problem, textile material use a major role here, okay. And here you can see there is a water in blue color and oil, it is mixed in yellow, they are mixed. Suppose oil spill is there in the sea. So, how to restrict, how to actually absorb this, how to remove this water spill from the water to protect the human being, or also total ecological balance we can maintain by textile material. So, super hydrophobic surface contact, so that contact angle 150 degree. So, we can make the textile material super hydrophobic. So, super hydrophobic material if we can use, it will its contact area is more than 1 50. So, we can treat the textile surface with some nano treatment to make it super hydrophobic. What will be the advantage? If it is hydrophilic, then it will absorb the water, and if it is hydrophobic, it will not absorb water, but absorb the liquid, that absorb the oil. So, we use the structure like hydrophobic and hydrophilic structure that. So, here hydrophilic. So, hydrophilic, hydrophobic, the structure if we use, that will help in absorption of water and adsorption of this oil. So, ultimately we will be able to get rid of the problem of oil spill, oil water separation can be done. So, oil absorption capacity here is 10 to 40 gram per gram of material. So, in 1 gram 10 to 40 gram of oil can be absorbed by the super hydrophobic material. So, this is used in the oil spill cleanup. So, here you can see it filters out oil water selectively. So, here it will actually absorb water, the hydrophilic, but it will not absorb this oil because of its hydrophilic, it will actually repel. So, and here due to hydrophobic portion, it will due to high contact angle, it will absorb the oil, it will totally it will separate out the oil water. So, hydrophilic hydrophobic layers are used, multi layer as I have mentioned, and main advantage of textile material here, it is actually reusable for multiple cycles. So, if we can clean the oil from from textile, so that we can be used multiple time, but effectively it can separate the oil and water, and it will use in oil spill cleanup. So, hydrophobic fibers repel water. So, if you are making the layer of hydrophilic and hydrophobic. So, hydrophobic fibers repel the water and hydrophobic fiber attract the oil. So, here we use the adsorption by textile material. So, adsorption, how does it adsorb? So, adsorption capacity is expressed by milligram per gram of the textile material. So, earlier what we have used by using the super hydrophobic fiber, we use the absorption of oil here. Now, here we are using the adsorption capacity. So, Freundlich isotherm is there to express the adsorption capacity. So, this is the relationship. So, amount adsorbed Q equal to K C power 1 by n, where K is the distribution coefficient, n is the correction factor, and C is the equilibrium concentration of adsorbate within the solvent. So, this is the concentration here. So, that means higher concentration will be higher, if the concentration is higher, the amount adsorbed will be higher. So, here the main advantage here adsorption depends on the surface functional groups. So, in the surface what are the different types of functional groups we use, on that adsorption will depend here. And here for this application, here we use the activated carbon that and in on the fabric layer, we deposit activated carbon, that actually will enhance the adsorption. That may be volatile material, okay, or maybe some oil spill oil. So, using the activated carbon impregnated textile material to adsorb the oil spill or any other volatile material, that can be done. The next area where our textile materials are used or fibrous materials can be used, and that is how to remove the heavy metal from water. So, that we will discuss in the next session. Till then, thank you.